Welcome back to AI Explained. Today, we're going to be taking a deep dive into something pretty cool,
Uh,
fine-tuning AI.
it is cool.
And it's kind of like, you know, teaching an old dog new tricks, but the dog is like this crazy, super smart AI model.
Yeah, exactly. And we're not even talking about building AI from scratch here. Fine-tuning is like we're taking a model that's already been trained and like refining it for a very specific task.
So almost like you have this like amazing chef who can whip up anything,
Right.
but now you want them to really specialize,
Yeah.
like say in molecular gastronomy.
Yeah.
Fine-tuning is like giving them that like extra set of skills
Mm-hmm.
to really excel in that like niche area.
And the beauty of it is that the chef doesn't forget everything they already know.
Right.
They're like building on all their existing culinary expertise, just like adding a new layer of specialization on top of it.
Like a perfect analogy.
Mm.
So let's say we want to fine tune an AI to, I don't know, write amazing screenplays.
Okay.
Where do we even begin?
Well, the first step is to like choose the right pre-trained model.
Right.
There are tons of models out there, each with their own like strengths and weaknesses.
So it's about finding a model that already has a good understanding of language and like storytelling.
Right. Exactly. We wouldn't start with a model that's been trained to identify images of cats.
Right.
We need a model that's already like comfortable with language,
Yeah. Yeah.
grammar, narrative structure, that kind of thing.
Okay, so we've got our model. How do we actually teach it to write screenplays?
That's where the secret sauce comes in.
Okay.
Fine-tuning with a carefully curated data set.
What does that mean?
So we're talking about like feeding the model a collection of existing screenplays,
Okay.
like the good, the bad, and the ugly.
So it's like giving our aspiring screenwriter a crash course in film history.
Exactly. By exposing the model to like this huge range of screenplays, we're
Right.
helping it learn like the conventions, the tropes, the
Mhm.
dialogue styles, all
Right.
the elements that make a good screenplay.
But it's not just about copying existing work, right? We want our AI to be creative and like original.
Absolutely. And that's where the art of fine-tuning comes in.
Okay.
It's like finding the right balance between learning from existing examples and encouraging the model to like develop its own unique voice.
Yeah, this is where I imagine things get a little tricky, right?
Yeah.
How do we like control that learning process and ensure that the AI doesn't just spit out like generic Hollywood tropes?
That's the million-dollar question. And the answer, my friend, lies in the mystical realm of hyperparameters.
Hyperparameters, that sounds a bit intimidating.
Mm.
Is this where I need a PhD in computer science?
Not at all. Think of hyperparameters as like the knobs and dials we use to fine-tune the fine-tuning process. They
Okay.
control things like how quickly the model learns how much data it processes at once
Yep.
and how much emphasis it places on certain features.
Oh, that's like we're the conductors of an orchestra,
Okay.
guiding each instrument to create a harmonious symphony of AI-generated brilliance.
Precisely. And just like a conductor needs to know which instrument to adjust and at what time,
Right.
mastering hyperparameters is all about understanding how each one affects the model's learning process.
Okay, so let's get specific.
Okay.
What are some of the key hyperparameters we need to be aware of when fine-tuning our AI screenwriter?
Well, one of the most important ones is the learning rate.
Okay.
It controls how quickly the model adjusts its internal parameters based on the data it's seeing.
So if the learning rate is too high.
It's like trying to learn a new language by cramming a whole dictionary in one night.
Okay.
You might grasp some basic vocabulary, but you'll totally miss the nuances and the subtleties.
And if it's too low.
The model might learn too slowly, taking forever to grasp even the most basic concepts.
Right.
It's like trying to paint a masterpiece with a single hairbrush.
Okay.
Technically possible, but not very efficient.
So it's all about finding that Goldilocks zone.
Right.
Not too fast, not too slow, but just right.
Exactly. And that just right setting often depends on the task at hand.
Yeah.
The data set you're using, and even the specific model you've chosen.
It sounds like fine-tuning is more of an art than a science.
It's definitely a blend of both.
Yeah.
You need the technical understanding of how these hyperparameters work, but you also need a bit of intuition and a willingness to experiment to find the perfect settings.
Speaking of experimentation, what about the data itself?
Right.
We mentioned choosing a data set of existing screenplays.
Yes.
Are there any specific qualities we should be looking for?
Great question. The quality and diversity of your data set can make or break your fine-tuning efforts.
Okay.
It's not enough to just throw a bunch of random scripts at the model.
So it's not just quantity, but quality.
Absolutely. We need to think about things like genre, tone, target audience, and even the era the scripts are from.
Right.
If we want our AI to write contemporary romantic comedies,
Yeah,
feeding it a diet of 1940s film noir isn't going to cut it.
that makes perfect sense. So we need to curate a data set that reflects the specific type of screenplays we want our AI to produce.
Exactly. And the more carefully we curate that data set, the better the results will be.
Okay.
It's like training a chef. If you only give them access to like cheap ingredients,
Right.
they're not going to be able to create culinary masterpieces.
So garbage in, garbage out, as they say.
Precisely. And this brings us to another crucial aspect of fine-tuning,
Okay.
understanding the biases that can creep into our AI models.
Biases. How do those come into play?
Well, remember that our AI is learning from existing screenplays.
Right.
And those screenplays are products of their time and culture, which means they might contain certain biases or stereotypes.
So if we train our AI on a data set of predominantly male-driven action films,
Yeah.
it might struggle to write compelling female characters.
Exactly. And that's why it's so important to be mindful of the biases that might be present in our data sets and take steps to mitigate them.
That's a really important point. We don't want our AI to perpetuate harmful stereotypes.
Absolutely. And this is where human oversight comes in. Fine-tuning is not just about setting hyperparameters and letting the AI run wild.
Right.
It's about being aware of the potential pitfalls and actively shaping the learning process to ensure that our AI models are fair, ethical, and inclusive.
Okay, so we've got our pre-trained model, we've curated our data set, we're aware of the potential biases.
Right.
What's next?
Well, now we get to the fun part, experimentation. Fine-tuning is an iterative process.
Okay.
We start with a set of hyperparameters, run the model, evaluate the results, and then tweak the settings based on what we observe.
So it's a bit like being a mad scientist.
Yeah.
But in a good way.
Exactly. We're constantly tinkering, observing, and adjusting to get the best possible results.
Yeah.
And the more we experiment, the better we become at understanding the nuances of fine-tuning and how to create AI models that truly push the boundaries of what's possible.
This is all incredibly fascinating. But I imagine fine-tuning isn't always a walk in the park, right? What are some of the challenges people might encounter when they start delving into this world?
You're absolutely right. Fine-tuning, while powerful, can be a bit tricky.
Yeah.
One of the most common challenges is something called overfitting.
Overfitting. What does that mean?
It's like that student who aces all the practice tests, but then completely bombs the real exam.
Oh, right.
They've memorized the answers instead of truly understanding the concepts.
So in the context of fine-tuning.
Overfitting happens when our AI gets so good at mimicking the specific examples in our training data set that it loses the ability to generalize to new unseen data.
So it becomes a master of the training data, but fails to apply its knowledge to real-world scenarios.
Exactly. And this is a trap that many aspiring AI fine-tuners fall into.
So how do we avoid this overfitting pitfall?
There are a few strategies we can use. One is to use a technique called early stopping.
Okay.
It's like knowing when to stop studying for a test.
Right.
You don't want to cram so much that you start forgetting things.
So with early stopping, we're essentially monitoring the model's performance and stopping the training process before it starts to overfit.
Precisely. We're looking for that sweet spot where the model has learned enough from the training data to perform well, but not so much that it becomes overly specialized.
Makes sense.
Yeah.
Any other tricks up our sleeve to combat overfitting?
Another powerful technique is called regularization.
Okay.
It's a bit like adding a bit of friction to the learning process, preventing the model from getting too attached to any one feature or data point.
So it's like encouraging the model to be more balanced and flexible in its learning.
Exactly. There are different types of regularization techniques, each with its own strengths and weaknesses.
Okay, I think we'll need to dedicate a whole other episode to diving deeper into regularization techniques.
Yeah.
But for now, let's stick with overfitting. Is there anything else we need to be aware of to prevent our AI from becoming a one-trick pony?
One crucial factor is the size of our data set.
Okay.
The more data we can feed our AI, the better it will be able to generalize to new examples. Think of it like this. If you're learning to play a musical instrument, practicing for 5 minutes a day won't get you very far. You need hours and hours of practice to truly master your craft.
So the more diverse and comprehensive our data set,
Yes.
the more robust and adaptable our AI model will be.
Exactly. And this is especially important when working with complex tasks like screenwriting.
Yeah.
We need to expose our AI to a vast and varied collection of examples to truly capture the nuances and complexities of the craft.
So for our aspiring AI screenwriter, we're talking about a data set that includes everything from classic films to indie darlings, blockbuster action flicks, to heartwarming animated movies.
Precisely. We need to give our AI a taste of everything so it can develop a truly well-rounded understanding of storytelling.
This has been an incredible start to our deep dive. We've explored the core concepts of fine-tuning, from choosing the right model to curating our data and navigating the treacherous waters of overfitting.
And we've just scratched the surface. There's so much more to uncover.
Right.
From the intricacies of hyperparameter optimization to the exciting new techniques that are constantly emerging in this rapidly evolving field.
That's right. But for now, we'll have to pause our journey here. Join us for part 2 of our deep dive, where we'll delve deeper into the world of hyperparameters and explore some advanced techniques for fine-tuning AI models.
Welcome back to our deep dive on fine-tuning AI. Last time we laid the groundwork, exploring the core concepts of like selecting the right pre-trained model, curating a diverse data set, and navigating the challenges of overfitting.
Yeah, we also dipped our toes into the mysterious world of hyperparameters, those knobs and dials that allow us to fine-tune the fine-tuning process.
And today we're going to roll up our sleeves and get our hands dirty with some of the most important hyperparameters you'll encounter on your fine-tuning journey.
I'm ready to get my hands dirty. But before we dive into specific hyperparameters, can you give us a quick overview of how they all work together?
Of course, think of hyperparameters as like the ingredients in a recipe. Each one plays a specific role in shaping the final outcome. You might have flour for structure, sugar for sweetness, and spices for flavor.
And just like with a recipe, getting the proportions right is crucial.
Exactly. Too much flour and your cake will be dense and heavy, too much sugar, and it'll be sickeningly sweet. The key is to find the perfect balance of ingredients to create a harmonious and delicious masterpiece.
So our job as AI fine-tuners is to become master bakers, carefully adjusting our hyperparameter ingredients to create the perfect AI model.
Precisely. And just like a master baker develops their skills through experience and experimentation, so too will we gain a deep understanding of hyperparameters through practice and observation.
Okay, I'm ready to preheat the oven and start mixing those hyperparameter ingredients. Which one should we tackle first?
Let's start with one we've already touched upon, the learning rate.
Yeah.
It's one of the most fundamental hyperparameters you'll encounter.
Right. It controls how quickly our AI model learns from the data.
Exactly. And as we discussed earlier, finding the right learning rate is all about finding that Goldilocks zone, not too fast, not too slow, but just right.
But it's not just a matter of setting a single learning rate and calling it a day, right?
That's right. Sometimes it's beneficial to adjust the learning rate as the training progresses.
Okay.
This is where learning rate schedules come into play.
Ah, yes. It's like starting a race with a burst of energy and then settling into a steady pace as you approach the finish line.
That's a great analogy. There are various learning rate schedules, each with its own strengths and weaknesses. One common approach is called learning rate decay, where we gradually decrease the learning rate over time.
So we're essentially telling our AI to take smaller and smaller steps as it gets closer to its goal.
Exactly. This helps prevent the model from overshooting the optimal solution or getting stuck in a local minimum like a hiker getting lost in a valley and never finding their way to the mountain peak.
Okay, that makes sense.
Sure.
Are there other types of learning rate schedules we should be aware of?
Absolutely. There are cyclical schedules that increase and decrease the learning rate, periodically mimicking the natural ebb and flow of learning. And there are adaptive schedules that adjust the learning rate based on the model's performance during training.
It sounds like there's no one-size-fits-all approach to learning rate schedules.
That's right. Choosing the best schedule often depends on the specific task, the dataset, and the model architecture. But don't worry, there are tools and techniques that can help automate the process of finding the optimal learning rate schedule for your needs.
That's reassuring to hear. Okay, so we've covered learning rates and learning rate schedules. What's the next hyperparameter on our list?
Let's talk about batch size. This hyperparameter controls how much data the AI processes at once during training.
So if we have a data set of, say, 10,000 screenplays, the batch size determines how many screenplays the AI looks at a time.
Exactly. We could feed the AI the entire data set in one go, but that's often not very efficient. It's like trying to read 10,000 books simultaneously. You'd be overwhelmed with information and wouldn't retain much.
Right. It's much better to read one book at a time, absorb its contents, and then move on to the next.
Precisely. And that's the idea behind using smaller batch sizes. It allows the AI to focus on a smaller chunk of data, make adjustments, and then move on to the next batch.
So smaller batch sizes generally lead to more stable and efficient learning.
That's right. But there's a trade-off. Smaller batch sizes also mean that the training process will take longer.
Because the AI is taking smaller steps and processing the data more slowly.
Exactly. So finding the right batch size is all about balancing speed and efficiency.
Okay, I'm starting to see a pattern here. It seems like most hyperparameters involve finding that sweet spot between two extremes.
You're absolutely right. It's all about finding the perfect balance. And that balance often depends on the specific task, the data set, and the resources you have available.
It's like we're walking a tightrope, carefully adjusting our steps to avoid falling off either side.
That's a great analogy. And the more we practice this balancing act, the more skilled we become at navigating the world of hyperparameters.
Okay, I'm ready to keep walking that tightrope. What's the next hyperparameter we should tackle?
Let's explore the concept of epochs. An epoch is simply one complete pass through the entire training dataset.
So if we have a data set of 10,000 screenplays, and we set the number of epochs to 10, the AI will see each screenplay 10 times during training.
Exactly. And just like with batch size, the number of epochs we choose can significantly impact the model's learning process.
So more epochs must be better, right? The more practice, the better.
That's not always the case. Think of it like practicing a musical piece. If you practice the same piece over and over again without taking breaks or trying new techniques, you might start making the same mistakes repeatedly.
You might even develop bad habits that are hard to break.
Exactly. And the same thing can happen with AI models. If we train them for too many epochs, they might become too specialized to the training data and lose the ability to generalize to new examples.
Right, we talked about that earlier. It's the overfitting trap.
Precisely.
Yeah.
So finding the right number of epochs is all about finding that sweet spot between underfitting, where the model hasn't learned enough from the data, and overfitting, where it's memorized the training data too well.
It's back to that balancing act again.
Exactly. And just like with the other hyperparameters, the optimal number of epochs often depends on the specific task, the data set, and the model architecture.
Okay, I'm starting to see a theme here. There's no magic formula for choosing the right hyperparameters. It's all about experimentation and understanding how each one affects the model's learning process.
You're absolutely right. Fine-tuning is an iterative process. We start with a set of initial hyperparameters, run the model, evaluate the results, and then tweak the settings based on what we observe.
So it's a bit like being a detective, gathering clues and piecing together the puzzle of how to create the perfect AI model.
That's a great way to put it. And the more we practice this detective work, the more skilled we become at understanding the nuances of fine-tuning.
This is all incredibly insightful.
Yeah.
But we've covered a lot of ground in this part. Should we take a break and come back for more hyperparameter adventures in part 3?
Absolutely. There's still a lot more to explore, including some fascinating techniques for preventing overfitting and optimizing our fine-tuning process. Join us next time for the exciting conclusion of our deep dive into the world of fine-tuning AI.
Welcome back to our deep dive on fine-tuning AI. We've covered a lot of ground from the core concepts of like selecting a pre-trained model and curating a data set to, understanding that delicate dance of hyperparameters like learning rate and batch size and epochs.
Yeah, and we've explored how those hyperparameters are like the ingredients in a recipe, each one contributing to the overall flavor and texture of our final AI model.
But just like any good chef knows, the secret to a truly exceptional dish lies in the subtle nuances. The attention to detail, the extra steps that elevate it from good to extraordinary.
Exactly. And that's what we're going to explore in this final part of our deep dive, those extra techniques and strategies that can help us fine-tune our AI models to achieve truly remarkable results.
I'm ready to unlock those culinary secrets. What's the first technique on our menu?
Let's talk about dropout. It's a powerful technique for preventing overfitting, that sneaky villain that can sabotage even the most promising AI models.
Right, overfitting is when our model becomes so focused on memorizing the training data that it loses the ability to generalize to new examples.
Precisely. And dropout helps combat this by introducing a bit of randomness into the training process. It's like adding a pinch of chaos to the recipe, just enough to keep things interesting and prevent the model from becoming too rigid in its thinking.
Okay, I'm intrigued. How does adding randomness actually prevent overfitting?
Imagine you're training a neural network, which is basically this complex web of interconnected nodes that process information. During training, Dropout randomly drops out or deactivates some of these nodes.
So it's like taking a pair of scissors and snipping some of the connections in that neural network web.
That's a great analogy, and by doing this, we're forcing the remaining nodes to work harder and learn more robust representations of the data.
Because they can't rely on those deactivated nodes to do the work for them.
Exactly. It's like a team of chefs where some members are randomly called away on other tasks. The remaining chefs have to step up, learn new skills, and become more versatile to compensate.
And this increased versatility helps prevent overfitting.
Absolutely. By preventing any single node from becoming too dominant or specialized dropout, encourages the network to learn more generalizable patterns in the data.
So it's like we're training our AI to be a jack of all trades rather than a master of one.
That's a great way to put it. And this versatility is crucial for ensuring that our AI models can perform well on a wide range of inputs, not just the specific examples they were trained on.
Okay, dropout is definitely going on my list of must-try techniques.
Yeah.
What other secret ingredients do we have in our fine-tuning pantry?
Let's talk about weight decay, another powerful tool for combating overfitting. It's like adding a dash of salt to our recipe, just enough to enhance the flavors without overpowering the dish.
Okay, I'm following you so far. But how does weight decay actually work?
Remember those weights we talked about earlier? The ones that determine the strength of the connections between nodes in a neural network?
Yes, they're like the volume knobs that control how strongly each node's signal is amplified or attenuated.
Exactly. And weight decay works by adding a penalty to these weights during training. It's like telling the network, hey, don't crank up those volume knobs too high, or you'll create a distorted and unbalanced sound.
So it's encouraging the network to keep its weights small and avoid overemphasizing any particular feature or data point.
Precisely. And by doing so, weight decay helps prevent overfitting and promotes a more balanced and generalizable model.
It's like we're teaching our AI to be humble and not get too carried away by any one piece of information.
That's a great way to think about it. Humility in the context of AI is all about avoiding overconfidence and remaining open to new possibilities.
Okay, I'm loving these culinary analogies. What other spices can we sprinkle into our fine-tuning recipe?
Let's talk about early stopping, a technique we briefly mentioned earlier. It's like knowing when to take your cake out of the oven, leave it in too long and it'll burn, take it out too soon and it'll be undercooked.
Right. It's all about finding that perfect moment when the cake is golden brown and perfectly baked.
Exactly. And in the context of fine-tuning, early stopping is about monitoring the model's performance during training and stopping the process when it reaches its peak performance.
So we're essentially looking for that point where the model has learned enough from the training data without overfitting.
Precisely. We're striking that delicate balance between underfitting and overfitting, ensuring that our AI model is both knowledgeable and adaptable.
This is all incredibly insightful.
Uh.
I'm starting to feel like a master chef of AI, carefully blending these techniques to create the perfect fine-tuned model.
And just like with any culinary art, practice makes perfect. The more you experiment with these techniques, the better you'll become at understanding their nuances and how to apply them effectively.
This has been an incredible deep dive into the world of fine-tuning AI. We've explored the core concepts, delved into the intricacies of hyperparameters, and uncovered some powerful techniques for achieving exceptional results.
And I hope our listeners feel empowered to embark on their own fine-tuning adventures armed with the knowledge and tools we've shared today.
Absolutely. Remember, the world of AI is constantly evolving, so stay curious, stay engaged, and keep pushing the boundaries of what's possible.
Thank you for joining us on this journey of discovery.
And be sure to subscribe to our channel for more deep dives into the fascinating world of AI.